Hi, and welcome back. In this video, we will be using artificial intelligence models to generate future trading forecasts. Large language models like ChatGPT use a powerful architecture called the transformer to predict the next word in a sentence. That's how they generate such a human-like text. More precisely, if we provide a sequence of words, the model will look for the most probable words that can complete this sequence. But what if we apply that same technology to financial markets? Instead of predicting the next word, we predict the next price or trend, and that's what we will be exploring in this video. We will walk through setting up a transformer model in Python using PyTorch, training it on historical price data of the Euro-US dollar, and using it to predict future price movements. So you will see how we can adapt the same techniques that power large language models like ChatGPT to our own trading and investing strategies. I'm also sharing the Python code I'll be using today in a link in the description of the video so you can download it, run your own experiment, and see how these models work. Transformers first exploded in popularity for natural language processing tasks. Let's imagine you're using a model like ChatGPT. You type in a prompt, and it responds by predicting the most probable sequence of words. In the background, transformers are analyzing all the words or tokens in your prompt, building something called attention matrices that determine which parts of the prompt are most important, and then generating the best possible continuation of your text. This attention mechanism is the key innovation. A transformer uses several heads or matrices, each looking at different relationships in the sequence. Think about a head as a matrix of parameters providing the importance value or weight of each word. If we're talking about text, one attention head might look, for example, at how nouns connect to verbs, while another head could track pronouns referencing earlier subjects, and so on. By splitting attention across multiple heads, which are basically matrices, the model can track a wide variety of relationships simultaneously. Now, why is that relevant for time series predictions like forex or stock prices? Well, price data is also a sequence, just like text, but instead of words, we have candle values over time. In theory, a transformer can be adapted so that instead of predicting the next word, it predicts the next price or a range of future prices. The same concept of attention applies. Each time step in the sequence can learn how to weight the importance of previous time steps. In other words, the model learns which past price movements are most relevant for forecasting the future. In practical terms, we will feed our past prices and any technical indicators into the transformer. The model will look across these historical windows and figure out which signals matter most. Then it outputs the most probable next price or price sequence, similarly to how ChatGPT picks up the most likely next words. Results can vary depending on hyperparameters, data quality, and market conditions, but there's no doubt that transformers represent a major leap forward for advanced sequence modeling. They can capture the long-term dependencies more effectively than older architectures like LSTMs or traditional recurrent neural networks. And I decided to try this on trading, to try transformers on trading data and share it here on YouTube today. Now let's jump into the code and see how these transformers work for trading applications. Grab your coffee, fire up your code editor, and let's get started. So this is our Jupyter notebook. We'll start by installing Torch, Pandas, NumPy, scikit-learn, and TA or Pandas TA for technical analysis just to compute some technical indicators. Now we can start defining some functions that we'll be using later on in the program. So load forex data, that takes a CSV file. It reads a CSV file, puts it into a data frame, cleaning and casting to date time format, the GMT time column. And then we're sorting the value by date, just in case. We're resetting the index and we return the data frame. Second function is adding technical indicators. It takes the data frame and it computes the RSI, Bollinger Bands high and low, the moving average 20, and the moving average slope. So that's just the difference between the current moving average and the previous one, two different rows or two consecutive rows. We apply some cleaning, filling missing values, and then we return the data frame with these technical indicators. Now, if you want to enhance this part, this is where you can add on your own indicators. Maybe you want to add, I don't know, different moving averages with different length, the exponential moving average, or any other technical indicator that you want to include in your study, so that the transformer will read it and try to understand the data or the price movement based on these indicators. For this video, I just kept it simple. I'm using those two. So I'm using, or three indicators. I'm using the RSI, Bollinger Bands, and the moving average. Now, this function, select and scale features, will take the data frame and the names of the features or the columns we would like to include in our study. We're going to take by default the open, high, low, close, the RSI, Bollinger Band, high, low, moving average 20 and moving average 20 slope. So that's the slope of the moving average. And then we're going to apply the minimum maximum scalar to these features, to these columns. We're going to apply the fit transform function with the scalar, the minimum maximum scalar on the data. So what this does actually, it will scale the values of these columns in between two boundaries so that no column takes more importance or more weight. Then from Torch utils data, we're going to import data set and data loader. And we're going to define a new class, forex data set, that inherits from data set. This is basically preparing the data so that it can be understood and read well by the transformer model. And these parameters actually are very important at this point. So the sequence length is, by default, it's equal to 60. That's how many rows we're going to read, the transformer is going to read before trying to predict the next row. And then the prediction length is 1. So we're going to predict one candle in the future. The feature dimension, by default, it's equal to 4, but it can be changed to 9, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 features at this point that we can choose to use part of these or all of these at the same time. And then the target column index is 3 because we're going to target the closing price. So what we're going to predict is actually the closing price of the very next candle. We're just applying one candle in the future for prediction length, and then we're going to predict the closing price of that particular candle. And then that's it, actually. This is the data defined here. And we're going to define the X, the input. So that's the sequence that we're looking to the closing prices actually of the last 60 candles by default. So that's the X part. And the Y part, the future price, is the very next candle closing price. So we're going to put these as labels. For the training, the model will be looking at X, but also at Y values to learn and fit what kind of sequences will yield what kind of future price or closing prices. And then when we are validating or testing the model, we just provide the previous sequences, and then the model has to guess the future price. So for the training phase, though, we need to provide the labels. This is called supervised learning in machine learning. And notice the return format is a torch tensor. So we're not working with NumPy arrays anymore. We're just using torch tensors because this is what we will be providing for the transformer neural networks. Okay, and now we will define our transformer model. So the class is time series transformer. It inherits from neural networks.module from Torch. And these are the parameters of the transformer. So the feature size is 9. Remember, we have 9 features by default. We have 2 hidden layers of neural networks. We have a D model of 64, number of heads 8. The dimension of feed forward is 256. Now, if you have noticed that 8 times 8 is 64, 64 times 4 is 256, and they are all multiples of 2. These are the rule of thumbs actually followed by data scientists and AI engineers while defining such kind of neural network architectures. Now, there is no theory behind, there is no clear theory behind actually, but these are good values for this kind of study. Now we can increase one of these, but we would have to increase the others. It's not mandatory, but it is recommended. Then in order to avoid overfitting, we have a dropout of 0.1. Sequence length, I've shortened it to 30 here instead of 60 to make things a bit faster while training and using the model. And the prediction length is equal to 1 because we're predicting just one step ahead, not more than that. So we're going to predict just one value. Remember that in ChatGPT, it can predict a sequence, which is a sentence. So you write 5 or 6 words and it's going to predict the next 6 or 7 words. We're trying to predict only one future value here to make it as simple as possible. Now, I'll not go through all the technical details here, but this is where our transformer is defined using PyTorch. So that's basically the encoder here with all the parameters. So the number of layers, the number of heads, the attention heads, and so on. Remember that we have mentioned the attention mechanism, and that was actually published by Google, I think, with the paper entitled "Attention is All You Need." And this is the architecture that was used by GPT, OpenAI, and so on and so on. So the number of heads is the number of attention heads. We're going to use 8 and not more. So we could increase these again just to check the relationships. Each head will focus on a relationship of the price, the current price, and the previous prices, or a certain sequence of previous prices. What comes before is basically reshaping the data and preparing the input of the model. But then this is the model. And then we have the output of the model right here. Again, I'll not go through all these details. It might get boring as a YouTube video, but the architecture is summarized here for now as is. And we're going to use this part for our trading. Now, this is where we're going to train the transformer model. To train the model actually is let it read the sequences of data, the closing prices, with all the input features, the 9 features, the RSI, the Bollinger Bands, the moving average, the slope of the moving average, and so on. And also letting it read the future closing price, the next step, just one step ahead. Why? Because it's going to fit the parameters of the neural networks. It's going to learn from this data what kind of sequence and what to expect, what kind of sequences we could have, and what kind of future values we could expect after these sequences. So in the future, whenever we have similar sequences or similar patterns, it's going to know how to predict what's the most probable next closing price. And this is where it's happening. It's in the train transformer model function. This function takes the model as a parameter, the value loader, the learning rate, 10 to minus 3, number of epochs, how many times we're going to keep repeating for the learning process, so 20. And now I'm training on the CPU. If you have a GPU, you might want to switch this to a GPU, but I've tried it on CPU. It's working on mine, so I'm not going to touch it for now. Now, after training the model, we're going to return the trained model. So that function is going to train the model on the data, and it will return actually the model. And now we have to evaluate the model. So to evaluate the model, we need to provide the model, the trained model, the data. So providing test loader. So that's basically the data for testing. Then we have the scalar, the featured columns, the target column, which is 3, the index of the target column, which is 3 because we're targeting the closing price, the window width, which is by default 10, so it could be 30 or 60, as you may have seen before. The starting index 0, the prediction length is still 1, and the device is still the CPU. And this function is actually going to take the model, a new set of data, and it's going to provide the model with the a length of sequence, 30 or 60 rows, depending on how we've trained the model. And then it's going to ask the model to try to predict the very next value, the very next closing price. It's going to compare this price with the ground truth price, like what really happened and what the model predicted. And we're going to compare these together. So obviously it's going to give us some metrics, but mostly we're going to plot the predicted closing prices and the real closing prices together. And now we have all the sets of functions that we'll be using actually to train and evaluate the model. So you don't have to understand all the details. I mean, it takes a certain level of expertise and to be familiar with artificial intelligence, machine learning, neural networks, especially transformers. Actually, these are some kind of a recent architecture. It's working for now. You can copy and paste the functions. And this is where we're going to use the functions. So this is the cell where we call the functions, tune the parameters, and this is where you can apply your modifications as well. So I'm loading a Euro US dollar candlesticks 1 hour data between 2020 and 2023. It's a CSV file. I'm using the load forex data to load this file. And then I'm adding the technical indicators using the function. Now you can see how easy it is calling the functions, providing the data frame, and returning a data frame with just the added and scaled technical indicators. Actually, they are not scaled. We'll be scaling these in the next function, which is select and scale features data frame. So I left it by default. It's going to scale the 9 features in the data frame. The target column index is equal to feature columns dot index of the column close, and we're going to use this later on. So then we have the sequence length is equal to 30. So I'm overriding all the default values that we've used before. Prediction length is still 1. We just want to make it as simple as possible. You might want to adjust it to 3 candles in the future or 5 candles in the future, but it's going to be a bit problematic to compare and to evaluate with the future values. Then we have the data set. We're going to use the forex data set that we've defined before, and we provide all the parameters, the required parameters that we have already. Then we split the data into training size. So that's 80% of the CSV file Euro US dollar that we have, 10% for validation, and another 10% for the testing size. So we have our data. We're splitting the rows into 80% of these are going to be used for the learning phase of the model. But then for the validation, we're going to check for 10% of these of the data. And then the last 10% are for the test size. So somehow we are letting the model learn on a big chunk of the data, but then we're testing it on another 10% and another 10% just to evaluate how the model would perform on new and unseen data during the training phase. Now, I've left this line here on purpose. Just don't do this. This is where we're going to split the data actually into 80%, 10%, and 10%. But there are 2 ways of doing this. Either we slice these sequentially. So the first few rows are the 80%. So these are the training set. Then the next is the validation. And then the next is the test. But by default, in machine learning, we have the habit of random splitting. It means like picking up 80%, randomly picking up 80% of the data points, and then randomly picking up another 10%, and then another 10% for the test set. But that's not the way we should be doing it. Why? Because in time series analysis, the sequence is very important. The way things are changing together is very important. We can't just pick points from different places or from different times of our data. This is not going to provide good results. And moreover, it's going to bias the results. Now we provide batch size, it's 32. The train loader is, we're going to use the data loader for the training data set, for the validation data set and the test data set. And then we create and train a transformer model here. So we're going to define a model time series transformer that we have created. That's a class that we have created previously in this code. We provide the parameters. And as you can see, the sequence length is equal to the one defined here. So that's 30 for now. Same for the prediction length as well. It's equal to 1. And if we have a GPU, we're going to use it. Otherwise, we're going to use a CPU. Trained model is equal to We apply the train transformer model. We provide the model that we have just defined, the data, the training data, the validation loader, the learning rate, number of epochs, and the device. And that's it. So this is going to take a bit of time, depending on how many epochs you're going to use. So I had to stop it a bit quickly just to get on with the video, the recording, and to show you how we can use the evaluation. So then we just have to call the evaluate model function. We provide the trained model, the test data, the scalar, and so on. And as you can see, we have two curves. So this one in blue is the real, these are the real closing prices. And the orange one are the predicted closing prices. And at first, you might say, this is working really great. I mean, the predicted closing prices are not very far from the real closing prices. But if you look closely, it looks like the model is a bit copying what happened before, in the candle before that. So take, for example, this predicted value, almost equal or a bit higher than the previous real value. Or even better, if you take this line here, so how things changed from this point up to this point, it's a copy and paste of how things changed between these two consecutive points. Same, this change here is translated into this change here. Then the price dropped in reality, and the transformer also dropped the price. Now, it might not be exactly a copy and paste of what just happened in the real price, but to me, it actually looks like the model is just copying how the price is changing very recently and just replicating this in the future step. It's not really showing any powerful predictive potential. Now, to be fair, at the same time, we didn't provide much for the model. Remember that for the technical indicators, we provided 2 or 3 technical indicators. We provided the closing prices and so on. So it's not enough to actually come up with a prediction. And the main reason neural networks always fail in this task is because you have a lot of noise in trading data. The price is very jumpy. It's going up and down. It's not showing clear patterns, nor repetitive patterns. And so any model that would somehow capture the details will capture noise. And it's going to be very hard for the model to make accurate predictions because it's really drowned and lost in the noise. It's trying to fit noise basically more than trying to fit a signal. This is why simpler models tend to perform better in trading. Now, there's a lot to be improved in here. First of all, adding the more technical indicators or custom indicators if you want, maybe changing the sequence, maybe changing some of these hyperparameters of the model when you are training the model or evaluating the model and so on. So it's a lot to be done. Maybe testing this on stocks data rather than forex data, providing the volume, centralized volume data, and so on. So there's a lot you can change and try to improve with. Don't forget to download the code if you are interested in this part and try to use it for your own experiments. And that's it for this one. I think it was one of the hardest videos I struggled to explain online, but I hope that it still brought you some value and sparked your interest in this kind of algorithms. Until our next one, trade safe and see you next time.